What are you doing?
I'm trying to siphon your gas, but I can't get it to work.
You're siphoning my gas?
Oh yeah, I probably shouldn't do that, should I?
Don't you understand the fluids phenomenon of what's going on? Okay, there are two ways to siphon gas. Remember that fluid always flows with a pressure difference, right? So you can either cause a high pressure in one car or a low pressure in another car. To cause a low pressure, you take one end of the siphon, stick it in one car, take the other end of the siphon, and suck until all the liquid comes through, and then it'll just continue to flow because of that pressure difference. To induce a high pressure, what you do is you stick one end of the tube in one car, the other end of the tube in the other car, and then use a separate tube to blow air into one gas tank, causing a high pressure, and the fluid will flow through the tube to the other car.
Cool! Gee, thanks, McCann!
So to understand the phenomenon of the siphon, we're going to use the Bernoulli's equations that take into account many assumptions as stated by the acronym SIN, which are steady, streamlined, inviscid, incompressible, no heat, and no work. Come here to this lovely diagram that we have pulled up for you. So as we are going to analyze this, we're going to start at atmospheric pressure and end at atmospheric pressure. The driving force is going to be the difference in the height of the fluid column from the start to the end here. So as we can see from this equation, 1/2 rho v squared equals rho g, the change in height. So our velocity is going to be the square root of 2gd. Yo, McCann, where are siphons used?
Where are siphons used? Well, let's do a Wikipedia search. As you can see, there are many different applications for siphoning. Siphoning coffee, don't drink it. Siphoning pump, inverted siphon, back siphonage, anti-siphon valve, other anti-siphoning devices, siphon barometer, siphon bottles, siphon cups, Heron siphon, Venturi siphons, self-siphons,
6.5 hours later.
and even some toilets use siphoning to get rid of your waste. But in this video, we're going to explore two siphoning examples in the human body and in nature that have been scholarly reviewed. Fungus is called the geosiphon, and it was given that name because it uses siphoning to live. This bottom part of the fungi contains liquid, water, and the top part, it contains other things that are used for photosynthesis. And the reason why this is called the geosiphon is because it uses siphoning to get water from its base up and around through its entire body so that it can continue to have the nutrients it needs.
McCann, that is sick. I actually just did a Google search of my own and I found a really cool siphon application. So here in the journal Biomechanics, they did a study on the carotid siphon, which is one of the main arteries that pulls blood into our brain. So that's a really important thing. And they did a CFD, or computational fluid dynamic model, to try to see how the fluid flows through this specific vessel. Took some notes. Let me read some of the things I found. So they found that this is a tortuous, they said the adjective tortuous vessel segment with sharp bends and large area differences. And then the article suggests that pressure differences caused from turbulences in the flow around the carotid siphon could be a factor that leads to aneurysms, in addition to the, of course, calcification of the artery. Siphons are everywhere, ladies and gentlemen.